Hey everybody, so in this video what we're going to be doing is we are going to prove the double angle identities for sine and cosine, and then I have another video coming where we're going to do the same with tangent. So here we have two angles with sine of theta plus theta. Normally you're used to seeing this, sine of A plus angle B, and you're used to working with either a sum or difference identity. Here, because we're adding, obviously we're working with the sum. So if I came over here, sine of A plus B, that's just sine of A times cosine B plus cosine A sine B. Let's write this out and then see what we can do to prove that double angle identity. So if I wrote this out to be sine of A times cosine of B plus cosine of A times sine of B, I need to plug in my two angles for A and B. But in this case, they're both theta. So what I'll do is I'll plug in theta everywhere I see an A and a B. So here I have sine of theta times cosine theta plus cosine theta times sine of theta. Well, now looking to see what we can do, these are the same term. Sine cosine is the exact same term as cosine sine because multiplication is commutative. So what I'll do is I will add these two together. So I'll say sine cosine plus sine cosine essentially is going to give me 2 sine theta cosine theta. And that is the identity for sine of theta plus theta is 2 theta. So my double angle identity for sine is 2 sine theta cosine theta. Now we can do the exact same process to prove the cosine identity. So here we can say, okay, we'll call this theta A, this theta B, and we'll write out our sum for cosine A plus B. So we have cosine of angle A times cosine of angle B minus sine of angle A times sine of angle B. So here both angle A and B have a value of theta. So we'll plug theta in here. So we have cosine theta times cosine theta minus sine theta times sine theta. Well, we know cosine theta times cosine theta is cosine squared theta, and we know sine theta times sine theta is sine squared theta. So here, if I said theta plus theta, that would give me cosine of 2 theta. Now, you may be noticing, what's the deal with the Pythagorean identity over here? Well, cosine squared and sine squared can each be rewritten if I were to say change the Pythagorean identity here. So if I wanted this formula here in terms of cosine squared, I could just subtract sine squared from both sides, and that will leave me with cosine squared theta equals 1 minus sine squared theta. We'll make that a little neater. There we go. Now, the same thing is true. What if I wanted to move the cosine over? Then that means that sine squared theta is equal to 1 minus cosine squared theta. So you see how I could take each of these values and I could substitute them into this formula. Well, if that's the case, that means that cosine of 2 theta has various forms. So this is going to be one form. Let's draw a box around this. Okay? Now what we're going to do is we're going to write out the other 2 forms. So what I'll do to begin is I will replace this cosine squared theta with 1 minus sine squared theta. So here I could also say that cosine of 2 theta is equal to 1 minus sine squared theta minus sine squared theta. Now you see I have like terms. negative sine squared minus sine squared. So here, cosine of 2 theta is 1 minus 2 sine squared theta. All right, that's another variation here. So we'll draw a box around this too. Okay, now what we'll do is we'll substitute in a 1 minus cosine squared for this sine squared. So if I came over here and I had cosine of 2 theta equals cosine squared theta minus, because this is a binomial and I am subtracting it, I'll make sure to put it in parentheses. So here I'll distribute the negative, and that gives me cosine squared theta minus 1 plus cosine squared theta. Now we have cosine squared plus cosine squared. This is 2 cosine squared theta minus 1, and that equals cosine of 2 theta. So you see here that there are 3 different variations for writing out the double angle identity for cosine. All right, that's going to be all for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.